FoodSafer. Záležitosť všetkých.
FoodSafer. Skupna zadeva vseh.
FoodSafer. O responsabilitate a tuturor.
FoodSafer, svi su odgovorni. FoodSafer, věc nás všech.
FoodSafer, kõigi ühine asi.
FoodSafer, mindenki ügye.
FoodSafer, gnugahtina.
FoodSafer, ikviena lieta. FoodSafer, visų reikalas.
FoodSafer, responsabilta ta' kulħadd.
FoodSafer, sprawa wszystkich.
FoodSafer, everybody's business.
FoodSafer, l'affaire de tout le monde.
FoodSafer, allas angelägenhet.
FoodSafer, everybody's business.
Food brings us together, whether it's a meal with loved ones, a quick bite on the go, or a gourmet experience. But what if every bite you took felt safer, smarter, and more trustworthy? Every day, millions trust that the food on their tables is safe. But with emerging hazards like new pathogens, chemical contaminants, and global supply chain complexities, ensuring food safety is more challenging than ever. Traditional methods struggle to keep up with these evolving threats. Introducing FoodSafer, a groundbreaking initiative funded by the European Union's Horizon Europe program, uniting 19 leading organizations across academia, research, and industry. FoodSafer is revolutionizing how we identify, assess, and manage emerging food safety hazards by developing state-of-the-art tools and frameworks. Our aim is to transform food safety in Europe and internationally by hosting a community of professionals who can work together in proactively identifying and managing emerging risks, ensuring a safer and healthier food supply for everyone. At the heart of this initiative is the FoodSafer Open Digital Hub, a centralized platform offering access to cutting-edge data and trend analysis, collaborative workspaces for professionals, guidance and training resources, proactive risk management frameworks. By fostering a global community, FoodSafer ensures that food safety becomes a shared responsibility. Join us in shaping a safer, healthier future. FoodSafer, making food safety everybody's business. Discover more at www.foodsafer.com. Follow us on LinkedIn.
Ladies and gentlemen, distinguished guests, colleagues and friends, good morning and welcome. It is my pleasure and honor to open today's event, Science Empowering Food Safety Systems, a dissemination workshop on food safer outcomes, tools and services. We are gathered here at the prestigious Chimay Paratech in the heart of Paris, a fitting venue for a conversation rooted in innovation, science, and cross-sector collaboration. This workshop is organized by FoodSafer and hosted by FoodRegSci, bringing together experts from regulatory authorities, research institutions, and industry, all united by a shared goal to strengthen food safety systems through cutting-edge scientific tools, collaborative networks, and practical solutions. Thank you all for being here with us, in-person and online participants. Your presence reflects a strong and growing commitment to science-driven food governance, and we look forward to a day of meaningful exchange, learning, and engagement. To begin, I would now like to invite Professor Samuel Godefroy from FoodRegSci to officially open the workshop.
Good morning, good evening, good afternoon to whomever is with us online, and also to all colleagues who are present here. It is a great pleasure and a privilege to welcome you in this illustrious institution that is Chimay Paratech, and in the library of this institution, where we are hosting our dissemination event for FoodSafer. As you all know, we are celebrating this month World Food Safety Day, which was identified by the United Nations on June 7th of every year as the day where all stakeholders, all partners involved, and even not so directly involved in food safety, to remember the importance of food safety for humanity overall. Being a project that, or contributing to a project that aims to develop and to promote tools that identify, assess, and manage the risks associated with hazards that may be present in food, it was only natural for us to organize our dissemination day on the margins of this month. Of course, this event also comes on the heels of the organization of our consortium meeting, gathering the various representatives of all the contributing institutions that are responsible for the development and implementation of FoodSafer. I know this will be presented later, but let me also present what FoodSafer is. It is an acronym, actually, meant to be hopefully remembered more easily, but it stands for the joined up approach to the identification, assessment, and management of emerging hazards and associated risks. As part of our commitment to ensure that the outputs of the research and development efforts are shared with the various users and with the global community at large, we are committed to contributing to dissemination efforts and to contributing to knowledge translation and knowledge sharing. And this is what we will be trying to do as part of this event. The Global Food Regulatory Science Society, which is a disciplinary group of the International Union of Food Science and Technology that I have the privilege to represent today, is actually a participant or a contributor to the efforts of FoodSafer, and is contributing with a number of partners in our dissemination efforts. I'm hopeful that today's discussions and today's material will give you some highlights of what we have been working towards, and also will encourage you to continue to be engaged with us in order to identify opportunities of collaboration, but also the opportunities of having benefit and taking advantage of the outputs of this project. With that, I would like once again to welcome all colleagues who are joining us online and also colleagues who are here, thanking you for your participation and your presence. And we will be starting this dissemination event.
The Global Food Regulatory Science Society, GFORCE mission includes knowledge generation and dissemination, underpinning food regulatory decisions, in support of food control systems, Our interventions focus on promoting food regulatory scientific disciplines. Consistent reliance on food regulatory sciences enables robust food control programs, contributing to more resilient food systems and a safe, accessible, abundant and nutritious food supply.
And now it is a great honor and privilege to invite Professor Rudi Krushka, the co-leader of FoodSafer, to make his opening remarks.
Yeah, many thanks, Samuel, for this very kind introduction. Ladies and gentlemen, dear colleagues, very glad today to talk to you about the project FoodSaver. As already pointed out before, this initiative has a very exciting term which includes hazards and associated risks. So you remember that a hazard, like a white shark, is not necessarily a risk as long as you stay, for instance, in Austria. And the same is with chemistry, with chemical contaminants, and that is why we need also occurrence data, we need consumption data, we need toxicological evaluation, risk assessment, and on top of that comes emerging hazard and associated risks. And this, dear colleagues, is something which we take care of in FoodSaver, and you see is kind of the explanation for this abbreviation, which we have chosen, the identification, assessment, management of emerging food safety hazards and associated risks. So food safe and R standing for risk and risk assessment. This project, also as already alluded to by Samuel Godefroy, is coordinated by the Austrian Competence Center for Feed and Food Quality Safety and Innovation with my colleague Martin Wagner and myself, and certainly with a fantastic consortium. We have a great team and very thankful to all the organizations who are involved and all the colleagues who are involved. I would like to switch to the next slide because yes, when we deal with food safety, one of the questions might be in the beginning, so do we have a personal interest in our food at all? And this is actually the result of the special Eurobarometer from 2022. And what you can see here is that in the European Union, 27, there is the indication that about 70% of the respondents say, yes, we do have an interest in food safety. Some 29% are obviously not that interested in this topic. We have France, where we are located right now. Well, clearly we had some fantastic dinner yesterday evening, also organized by G-Force and colleagues, when we were thankful for that. And you can clearly see that obviously in France, the personal interest in food, and particularly in safe food, is more pronounced than on average in the European Union. I come from Austria, so we have slightly less people who are interested in food safety. Maybe the perception is that our food is safe anyways, so there's a lot of room for interpretation, but this is as a teaser for what's coming right now. So do we have concerns about food safety? That's another outcome of the Euro special barometer. And always on the top of the list is pesticide residues in food. Although from a food safety standpoint, I might say this is something which does not come on the top which would not make it in the top 10% of the priority list of those contaminants which matter the most from an exposure and toxicological point of view. Then comes other contaminants such as antibiotics. You also see here food poisoning from food or drinks contaminated with bacteria and viruses, microplastics in food and found in food, and then the presence of antibiotic resistance. And you see a long list of other potential contaminants which are considered less and less important. And I'm quite well known as a mycotoxin guy, so those toxins which are produced by filamentous fungi. And you see that although from a toxicological point of view, mycotoxins do matter much more with toxicology, which is at least usually 50 to 100 times more toxic than pesticides, and also on top of that, some of those are cancerogenic. This comes rather at the end of the list. Poisonous molds in food crops the perception is that these substances are actually not justifiable, less important from a consumer perception point of view. How does the rapid alert system for food and feed work? I think this is one of the assets of being member of the European Union. I would say this real-time information among member states if some contaminants which exceed regulatory limits pop up at the border or are reported by the member states. You see actually on top number one, it is pesticide residues. So there is the greatest concern from an objective point of view, from a toxicological point of view for consumers. That's a different story. But notifications, yes, it comes at number one. Then comes pathogenic microorganism. So FoodSafer takes care of emerging microbial risk emergence and persistence. And then comes mycotoxins still on the podium. And then like novel food proteins, metals, allergens, environmental pollutants, and so forth. So you see that in FoodSafer, we particularly also take care of those contaminants which are on the podium of this rapid alert system. So what is an emerging risk? Well, emerging hazard and an associated risk, as I said, well, a hazard is not necessarily a risk. First of all, you have to identify the hazard and then to find out and to clarify whether there's also a risk associated to the consumer. Here, the European Food Safety Authority and the European Food Safety Authority is also part of our International Advisory Board team, has defined an emerging risk as a newly identified hazard plus significant exposure. That could be a new virus which has been found or a new toxin with significant exposure, which actually would then be associated also with a risk. It could also be a known hazard which becomes worse in view of climate change, such as aflatoxins, plus some significant exposure as a result of global warming and particular fungi, which develops more frequently as a result of that, or a known hazard combined with increased host susceptibility, for instance, drought stress of plants, which makes them more susceptible, again with significant exposure. So what we are doing here in FoodSafer is also to take advantage of known chemical hazards from the data bank established by Review Food Safety Authority, EFSA, and also from the RAFS, the Rapid Alert System Food and Feed Data Bank, and to feed that into our system and to take advantage of this as a foundation of what we are doing. We also had consideration, or have been having consideration, on the chemical and microbial risk emerging. You could say that this is a risk escalation ladder where we are looking into conditions and stressors, or so-called pressure indicators, which could be at the bottom of this risk ladder, a known hazard which still needs to be properly addressed in the context, for instance, of including consumers, or to still to having to develop regulatory limits. When we go along the risk escalation ladder, we are facing known hazards which become worse due to the increased stresses exposure in the food system as a result, as I've alluded to before, of global warming, to give an example, or an emerging risk due to new hazards which have just recently been identified, or changing consumption patterns. Just think of newly introduced protein sources, for instance, from insects or others. And then comes the super risk. And I think super risk doesn't need much explanation. We just have to think back a few years back in the COVID crisis, which obviously has developed on the food market. That is something at the end of the risk escalation data, and there's out of control situations, again, also with the other steps on the risk escalation data are to be considered, and also are in the view of FoodSafer. Here you see nice consortium at the kickoff meeting in Tulln near Vienna in Austria, where we have gathered. This is 3 years ago, so now we are approaching year 4 of our project. There are 18 organizations from 14 countries which are involved in FoodSafer, from academia, from industry, from stakeholder organizations, and I think it's a very great and interdisciplinary consortium, which is also supported by an advisory board. I think we will come back to that also in some other presentations, representing also a number of institutions from the Food and Drug Administration, Health Canada. There is also EFSA, there is the UK Food Standards Agency, Food Drink Europe, just to mention a few, also Singapore Food Agency, and they have also gathered this meeting here in Paris to give us advice and also feedback as we go along the project. These 20 members of the advisory board provide advice issues as we go along. There was another meeting which we had almost 2 years ago in Barcelona, in Spain, at the premises of IRIS, which organized this, and which is also partner in FoodSafer, where we asked the advisory board by filling out questionnaires what is on their agenda, what do they conceive as important emerging risks. And just to make a long story short, the summary of what was concluded is laid down here. Salmonella, well, not a big surprise, but nonetheless found also by the advisory board, was the most frequently identified bacterial hazard. It was also found that the significance of viral and protozoan threats of the global food supply is definitely under-reported, and they also pointed out that natural, including fungal, plant, and algal toxins, and also perfluorinated alkali substances, the so-called forever chemicals, which are considered as more and more important, were top-ranked among the chemical threats, and we will be having some in-depth discussion and presentation on the chemical and also microbial threats in a few minutes. So let me summarize. Our FoodSafer project focuses on the anticipation of foreseeable changes in the European food supply chain. That also includes alternate protein sources, just to give an example. Also to identify stressors and drivers and indicators for the emergence of food safety hazards and related risks. And what we have been doing in the last 3 years is to design a holistic, proactive risk management framework, of which the digital hub, which will be presented later on today, is integral part of that. And also we have been dealing with the improvement of support regulatory bodies and capture multi-actor users. So this is actually this full picture and the framework which underpins our activities. Well, this is just in brief. You have here the drivers and trends, which are social, technological, economical, political. We are to see and to identify the emerging hazards as a result of these drivers and stressors, particularly chemical and microbiological hazards. And then at the end of this chain, if you like, we are dealing with risk mitigation and resilience strategies which we propose, like risk management policy, food safety management. And you can see here also an example. We have population growth, climate change, resource depletion. So one way which we see here is consumption of edible insects, also in the feed arena as an alternate protein source, which by the way is also interesting detoxification properties. And the question is what is the potential food safety implication of this novel protein, just to give you here some concrete example. So this is the basic structure of the emerging hazards in the microbial and also chemical arena, which we have been taking care of in FoodSafer. We have here the FoodSafer framework on the left side, which actually identifies these already mentioned drivers and trends, of which there are many. Well, let's say just the social area, consumer behavior is certainly part of that, demographic development is part of that, also health and well-being and so forth. In the environmental area, it's certainly climate change, and there's some other examples being given here. The emerging hazard identification, well, there's the chemical arena with environmental pollutants, process contaminants, illegal addition of toxic chemicals, microbial and parasite hazards, physical risks, including microplastics and also allergens. So certainly we are aware of all these information and all these threats which we address, but particular case studies are being addressed also with laboratory work and mitigation strategies by looking particularly into process contaminants, illegal addition of toxic chemicals, chemicals of biological sources such as natural toxins, and also AMR is being particularly considered in FoodSafer as studies in which we develop both identification, assessment, and also management strategies. So if you will, FoodSafer framework adds also this information, which is also managed and also providing information to stakeholders through the digital hub, which provides all information then to stakeholder organizations or regulatory framework programs, including also the European Food Safety Authority. What I like, just one glimpse into the FoodSafer digital hub, that you get this online information on existing and also emerging risks, hazards, whether it is a newspaper report or a scientific paper. This is something which is, I think, interesting not only for the academia but also for industry regulators. Don't let us not forget that also regulation can be an emerging force. You know all about this. So let me thank and to conclude my presentation by thanking this excellent consortium of FoodSafer. Also, I would like to acknowledge the European Union for providing the funding. I just would like to point also out that we also take care of other initiatives. Obviously, my pointer is running out of steam. Also with a doctoral program which we have been developing in BioDocstock. If you are interested to sending students to us, also in collaboration with FoodSafer, please contact me later on the information. Yeah, now it works. There it's called BioDocstock, Safe Food in a World of Changing Climate. It's a doctoral training network to develop actually and novel control mitigation and risk management method for biotoxins. So this, if there is on the line, it's an online event, people who would like to apply, please contact me or just look at our webpage. That being said, I would like to now hand over to the next speaker, and many thanks for listening, and please stay with us and watch our latest improvements in FoodSafer and our activities. Merci beaucoup.
Up next, it's my pleasure to welcome Ms. Cristina Fernandez, representing Aeris Technology from Spain. Cristina will be sharing practical guidance for users of the FoodSafer Hub, a valuable session for anyone looking to get the most out of the platform. Please join me in giving her a warm welcome.
Hello, thanks Rudy for the nice presentation. It's been a very good introduction for this presentation now. I'm going to present you the hub. And what is FoodSafer? FoodSafer is the world's specialized community of food safety professionals. And you can see here at the bottom of the presentation, the link where you could join and register and then start using the hub. How are you going to use the hub now? So I'm going to explain you. First of all, what is FoodSafer? The digital hub. So it's a hub that aims to be a trusted source of information, guidelines, and advice in relation to emerging hazards that are posing a risk for food safety. So at the moment, and I'm staying in this presentation a little bit so that you could join into the link and save it for later, where you will see also at the home, which is the first section, one post in which there is posted the instructions to download the mobile app, because the idea of this digital hub for the food safety community is that you wake up in the morning, you see all the news, what's happening in the world. If, for example, I am in the US, what's happening ahead 6 hours in Europe, no? So you will see all the different news that are happening at the moment, and you will be ahead of the curve for the food safety trends. Now that you already saved the link and you will register later, I'm going to explain you the different sections of the hub that at the moment it's 70% completed. So this is today the early launch of the hub, 100% complete next year. And you could see that on the top of the screen, we have different sections. The ones that are marked are already complete and the other ones are still under development. Just a briefly explanation of the ones that still haven't been developed. The signal trends. Signal Trends is a collaboration that we have with a sister project, Holy Food. So we are bringing the machine learning methodologies that they have developed here so that you will be looking at all the weak signals from the different risks and hazards. And why it's important, this digital hub? Because signal trends, which is related to machine learning, are not taking into consideration human beings. This hub is doing that. So this is a collaborative framework that could make you collaborate with all your colleagues worldwide. The other section that still hasn't been yet developed is the framework, and Rudy was explaining it before with a nice picture that was chosen during the execution of the project regarding the different drivers, trends, and so on. So basically, this is going to be a customized dashboard in which you will choose the different tasks that you want to be notified about. Because if you are an expert in mycotoxins, for example, and you want to be more into that field, then maybe you just want a dashboard for that, and you will have all the different news from the different sections of the hub in real time for that. Okay. Then the toolkit is going to be a section in which you will see different training resources, and yeah, this is basically the different sections that still are under development, but the rest I'm going to explain them now, so you could start using them. Here you see the home. We have developed a nice feature which might be similar to you regarding another social media, and you could react to posts. And this is a nice feature because we are acting as the owners of the hub, because we are moderating the content, okay? Not just liking or recommending different comments from the colleagues. Also, there is a wizard in which you will see the different guidelines that I'm showing you right now. Once you have doubts, you just come in here and you understand how to use the hub. If this is okay, and okay, let's take a look at the home. You could edit your profile from the bottom left. In your profile, which I'm not gonna go now, you could choose the hashtags as well as the tags for the framework, and you will see also your profile picture and other things. Also, you can choose the language, and there is a mark icon here that you could click for technical support, and we'll receive it and we'll get back to you if you have some issues. Also, there is a notification bell here. For example, if you are commenting a post and someone is replying back to you, you will see it here or in any other comment in our workspace as well. Okay, now let's try to create a post. If you click here, you see that you could use emojis of different typography. Also, you could add images. Not just you can do it from the post, also from the top bottom. And also you could engage into the comments of other users. If it's a post that it's really interesting to you and you want to share, you could do it. As well as that you could reply back to any comment and a comment to a comment and organize, have all the comments organized. Okay, now I will show you the hashtags that you could see here on the top. This is also an amplification feature, and they are showing you the trending ones, okay? So the ones that are more posted or more users have liked them. So this is working as a nice feature because you will see what's more trending. You could save the posts that are more interesting to you. Also, if you are making a post and you didn't finish, save it as a draft. Also, if you want to search for a post, you could do it here on the search bar or just the latest one. Well, these are the trending section. That the trending section, you could just change it according to your different interests. They change, not just here, also in your profile section. This is a very interesting feature that you could see here on the right side that we really like, because it's the news feed, the RSS feed that are posting it. They are posting in real time, and they are coming from different sources that have been chosen by the FoodSafer consortium during these last 2 years. So they are curated, and it's very interesting because just wake up in the morning, you see all this, you scroll down, and as a first glance, you have a view of what's happening in today. Okay, so just by reading the highlights, the titles of the news, you can quickly see what's going on, because this is coming from different sources that are trusted. And then also you could share them on social media, different social media, such as LinkedIn, Twitter, and then, yeah. So now I will go to the next section, which are the workspaces. What are the workspaces? The workspaces are a different kind of communication compared to the home, because you could choose if you want to talk about a specific topic and could be public, or if you want to talk about something more private, you could do so as well and invite your colleagues on that. And if it's private and you see that there is a workspace that is talking about some topic that you are interested, you could ask to join, and the admin will accept you or not. Okay, here on the top left, you could see that you have the list of my workspaces, or all of them. You could filter them by public or restricted, also by keywords, because it's very difficult to find them when there are a lot and scrolling down. You just need to use a filter to search them. Now let's see how to create one. You can click here, create a workspace, and then follow the simple steps of give it a name, brand the workspace with a logo, explain the mission of it. Now that it's set up, you could start a discussion. This is very similar to the home, so I'm not gonna go with it, but it works in a similar way. Also, you could attach documentation for the posts, and they will directly then upload it to the repository of each workspace here. Also, you could reply to a comment and keep the conversations organized in the discussion. with the three dots, the same than in the home. Also, you could save the discussions in your own workspace, and then if you are starting a discussion, you could save it as draft. Similarly, you could search and filter them by keywords or the latest ones. And then on the left, you could see the different discussions organized, and you could scroll down and easily look for them. Also, you could alternatively add notes private to you or to the different users that are members in the workspace. Here on the top right, you see the different members, where also if you click there, you could invite more members. There's also a chat, not just in the workspaces as different channels, also individual chats. And if you click here on the top, the three dots, you could leave it anytime. Okay, now let's move to the repository, which is a very nice functionality of the workspaces, because you could have different folders to organize all the documentation, not just from the different posts. Also, you could start uploading them there, here, by from your desktop, your Google Drive. It has different features to search and filter as you want, by document type of documentation, by the newest, or by date. Okay, so this keeps you organize you better the workspace, and also you could own everything or just delete it. There's also another interesting feature that we have at the workspaces, which is a video conferencing tool. So you could organize meetings and brainstorm your ideas through a mural. Okay, so here, well, you add the title, the description, the date, the venue. If it's online, you could also add a link from this video conferencing tool, or if it's Meets or Teams or anything. Also, you could invite people here and see if they are attending or not. You could wrong adding them, so you could delete them as well. And basically, yeah, you will see if they are coming or not. And this is I'm not showing you everything, but also you could link this to your Google Calendar and other calendars. Okay, so they will appear you there with the link as well. Okay, finally, let's finish with the latest section of the network, because this digital hub is not just helping you to be to collaborate with the people regarding risks and hazards. And for example, I was at a conference recently, and they were discussing like, okay, we have the different rules like at the laboratories, and there is this rule, but there are exceptions to the rules. Sometimes they don't know what to do, and for the control of the different contaminants, and this was a good point in which these discussions could be performed. Okay, because there are exceptions to the rules. What do you do? So if you want to find the right expert, then you go to the network, and you could just look for not just members in the hub, also organizations. So as an example here, you can see the details of my profile. You could contact me in this case. Why? Because in my profile, I chose the option like I can be contacted directly, okay? This is one of the things that it's important to know, and I was not showing you the profile. But if you don't want to be contacted, you won't be contacted, okay? So it's anonymous in the case that your details. So it will be as default like that, but you have to activate it if you want to be contacted. And this contact could be through the chat of the workspace. Via direct message that you will receive in your email, but again, the email is nobody will see it anyway. You just will receive an email, okay? Or the chat. And also you could look for organizations here. Here we have the EFSA. They are a very good partner who are engaging in the hub with comments and the relevant information. Also, if you belong to EFSA, then you could also add it in your profile, no? So basically here at organization. And here you have the features to look for the users, the organizations. How? By searching by keywords or by address, according to the kilometers that you want to choose. And also you could clear the search or search here. Once you finish adding everything. And just to finalize with a couple of slides regarding the new functionalities that we've developed recently. And one of them is the data lab. That's why I was not explaining you at the beginning, because you have all the different databases that, again, in the similar way than the RSS feed that you have at the home on the right side, we have chosen different databases, different links to access to them according to the consortium. So this and also the International Board of FoodSafer. So we've been deciding together all the different relevant databases in the same manner of the rest of the hub. So quickly you could access to them and you have all information related to food safety in a hub. And the last features that we've recently developed is the chat of the workspaces. So basically, you just can access there from the portal or here, okay? And in the future, we are developing a tool in which we will have an app with the chat of the different channels of the workspaces, not just the mobile app, which I really recommend you to download, because then it's going to be easier to access and share content from your phone, from your smartphone, rather than the computer. Okay, so this is my presentation. And any doubt that you have, you can contact me, not just the question mark icon from the hub. And I hope you enjoy the hub after you register and start sharing content that we all want to know. Thank you.
Now, let's turn our attention to an important session on food safety. We are pleased to welcome Rudolf Kriska and Lauren Alteo from FFOQSI Austria, who will be presenting on the FoodSafer food safety approaches in chemical and microbiological risks. Please join me in giving them a warm welcome.
Yeah, many thanks to this charming AI lady for the warm welcome, and also warm welcome from my side. Now let's immerse ourselves like in the topic of the emerging food safety hazards and associated risks. I'm happy to kick this my part of that particular session off by introducing you into the chemical risk, whereas Lauren Arteo, she will be presenting the second half of this presentation, so that this title, which you see on screen, is justified. Namely, that this lecture is about food safety approaches in chemical and microbiological risks. So I have pointed out before the architecture of FoodSafer, but by not showing you this technical flowchart here or diagram, you see here that clearly as a European Commission funded project, or clearly as actually a huge initiative, we do not only have one work package where we have several work packages. So first of all, when you see on work package 1, we deal with the impact analysis of food system stresses and also future-proof risk management. That is a very important task. Drivers, stressors, which is carried out in work package 1, and then we have 2 work packages. Work package 1. Work package 2 dealing with microbial hazards, and work package 3 dealing with chemical hazards and associated risk emergence. So these are these 2 work packages where we also carry out our case studies, as already alluded to in my opening speech this morning. We have also pointed out that we have this open digital hub, which was also kindly presented by my colleague from IRIS, Cristina Fernandez, for enduring delivery of project outcomes and also transformation. And then we have the de-escalation concepts in future proof food safety management and lifelong learning. We have also learning material, which we provide on our digital hub. It's not open yet, but this will be part of the next version of our digital hub, so that we can also contribute to curricula, to citizen science, and so forth. So let me now do something which you might consider as an advert for my own book. Maybe it is, but it's actually the foundation, I guess, of what we are doing in Europe. Not my book, but the findings and the fact that our food, even in highly developed Europe, can not be considered as toxin-free, although this is a brand used often by some companies, food companies, particularly on the web. So what we have tried as authors was to look into the health risks and benefits of our food. So not only risk, but also benefits, I have to point out, and also to come up with something like a risk ranking for the average consumer. Clearly, national authorities, international authorities would not dare to come up with a risk ranking. As a university professor, I can do that. But certainly this book and this risk ranking is based on a paper which was published in a high journal, Critical Reviews in Food Science and Nutrition, where we actually have summarized the dietary exposome assessment of chemicals in food and to provide an update on the chronic health risks for the European consumer. And we have come up actually with this indicative chronic risk ranking of food contaminants. It has to be pointed out that this is true for the average adult European consumers. If it were also for more vulnerable group, this book would actually be much bigger and much thicker than that, and which is based actually on some 100 reports which have been developed or reported by European Food Safety Authority. And this number one, and that's actually what I would like to point out of this risk ranking. We have not pesticides, which comes as a surprise, I think, for many consumers, but it is actually a food process content. And number two, mineral oil hydrocarbons, especially the aromatic fraction, as a result of their genotoxic carcinogenic properties in animals, and also because of their widespread prevalence in many daily consumed foods. Number three on this ranking is aflatoxins, also in view of climate change, by the way, due to the exposure of these toxins from highly consumed wheat-based foods, and which is also, by the way, a genotoxic carcinogen. So this is the podium. And number four, dioxins, and dioxins like polychlorinated biphenyls, PCBs, nickel, some brominated flame retardants. Number five, pyridine alkaloids as a natural toxin, and number six, PFOS, and also the both perfluorinated octane acid compounds, forever chemicals, and also heavy metals. So why I'm saying this? Because this is also quite a nice foundation of what we're doing in FoodSafer, because we'll see that we are dealing with pyridine alkaloids, we deal with aflatoxins, and we deal with emerging toxins in view of climate change, and also in view actually of my presentation now, considering in this first part of this talk the chemical hazards and associated risks. I would like to come back to the definition by European Food Safety Authority on what is an emerging hazard and associated risks. I'm not going to repeat that, but well, we talked about new identified hazards and significant exposure in the world of toxins, of natural toxins. That would be, for instance, here newly identified hazards such as NX2, a novel mycotoxin which has been discovered recently, or DON3-glucoside, the known hazards plus significant exposure, again an emerging risk, in this case aflatoxins, although emerging toxins are usually considered as those which are not regulated. Clearly, aflatoxins is regulated, but in view of climate change, we have a known hazard plus significant exposure. So aflatoxins would definitely qualify as being considered as an emerging toxin. And then there's a known hazard and increased susceptibility. You could say this is homonicid, which is another important toxin group in view of, for instance, maize, which is more damaged through insects, which are moving towards the north. So again, Russ data banks, as already pointed out before. I'm also showing this risk escalation letter to give you, to exemplify or to provide some examples to what I've shown you before, because we said, okay, we have a known hazard at the bottom of this risk ladder, which still needs to be properly addressed, and that is, for instance, this DON3-glucoside, which is a conjugated masked mycotoxin, which is already known in the meanwhile, but it is not properly addressed. It's in the process of being addressed. It's also now part of some parameter of regulation. A known hazard which becomes worse, again, aflatoxins, as already pointed out also before, and a new hazard which with potentially high consumption patterns and but that is still to be proven. So there are examples along this risk ladder, and this is true or in the arena of antimicrobial resistance, where you can, in case of microbial risks, easily also reach the top of this with so are moving toward recently. It's actually a very interesting picture. Some of you might know the outcome of the at a velocity of 2.7 kilometers per year was supposed. We can see some indicators for ambassadors, so to speak, of what's happening in the future through extreme due to unprecedented expectation. This curve is actually true for fungi, viruses, nematodes, bacteria. So this is also a very important scenario and stresses to be considered in view also of the FoodSafer project. So when we move on. So this is. No, you can. Okay. So you see how dangerous climate change is, even for the presentation. This shows also the scenarios with respect to maize. MAP actually reporting the risk of aflatoxin B1 at the +2 at the +5 degree Celsius scenario. +2, well, we see moving these red spots of high aflatoxin concentration towards the north, +5. Well, aflatoxins, well, this is almost inconceivable, reaching even northern parts of Europe. But that is something which we have to brace ourselves, because you see +2 degrees Celsius scenario, +3, it's not something which is science fiction anymore. It's most likely reality in the future. So that is also why the European Food Safety Authority has concluded that climate change is expected to have an impact also on the presence of genotoxic carcinogens such as aflatoxin B1 in Europe. So the backbone of our work in my own institute at Boku University of Foxy is and has always been the analytic instrumentation and methodology, which we have actually developed in a manner that tandem mass spectrometry is now capable, simultaneously fast and most sensitive, to determine some 1,200 contaminants, including hundreds of pesticides, of natural toxins, including plants, bacterial and also fungal toxins, but also of pharmaceutical drugs in 45 minutes. Believe it or not, just now a thesis has been completed, which can now determine actually and not only detect, to quantify actually the accurate concentration of some 930 of these contaminants in 11 minutes. And this is also what we have been using in FoodSafer as a part of our climate change monitoring to provide our partners, including also Gorilla, one of the presentations Michele will be giving later on, which take advantage of that. And that also enables us to come up with novel information on the occurrence. let us not forget, if we're talking about a hazard and the associated risk, for the risk we need occurrence data. And for the occurrence data, especially in view of emerging contaminants, what we do need is ideally to have the entire spectrum on the radar of those contaminants, especially in this case secondary metabolites, which are there. And as a matter of fact, this FAO figure dating back some decades ago, saying that 25% of the crops are contaminated, is definitely to be amended to a figure of 60 to 80% as a result certainly of improved analytical methodology, but also as a result of global warming, as pointed out before. Well, clearly such papers get highly cited. And that now I would like to just briefly guide you through the case studies in the emerging risk arena for chemicals here in the FoodSafer project. So we have here kicked off the climate monitoring program for checking durum wheat samples, which is particularly used for the production of pasta. That's where we have a pasta producing company also on board. In Italy, Greece, Turkey, and also common wheat samples from France and Germany. We also monitor tomato samples from northern Italy over a period of 4 years, which are collected and also directly at the farm level provided. Ideally, we shall combine this with GPS geolocalization coordinates for also monitoring with satellites, which is actually a challenge itself. Samples analyzed with LCMS, I've already pointed that out. And we also ideally would like to come up with these improved prediction tools, forecasting tools, which takes advantage of big data, including ground truth data and satellite image data to provide actually information on the impact of climate change on natural toxin production, and also to improved forecasting, which actually would ideally then lead to something like this, where we have actually a big data and AI-based prediction tool as an improved decision support system, where actually the Sentinel data, which are monitored by our partner Bioscience here within FoodSafer, and combine this with ground truth data from mycotoxins. We also know the fungal life cycle. We know information about the soil. We know information about the genotype of the crops, and also we do have historical and actual weather data, and then along the chain, harvesting, monitoring, also during transport and storage, and also artificial control laboratories, where, for instance, you need lateral flow tests for rapid testing and quick decision. This is case studies too. So we are also dealing with thermal degradation of mycotoxins gluten-free pasta. I'm not spending too much on this because my colleague Michele Suman, work package leader of our work package number 3 from Barilla, he will be referring. Referring to the degradation studies which we do in FoodSafer to come up with the information on what is the extent to which microbes are degraded during thermal processing, and also ideally to clarify the structure of these degradation products. Study number 3, we're switching from mycotoxins, which are produced by fungi, to tropane alkaloids produced by plants. This is actually, again, a toxic secondary metabolite. The main source of these tropane alkaloids is this invasive Datura stramonium. I don't know whether you had Latin at school like me. It was quite boring, but sometimes useful when you are entering the arena of plant toxins and so forth. Which is also thorn apple, Simpson's wheat, which are promoted by climate change. The contamination through tropane alkaloids actually happens during the harvesting of the crops, buckwheat or millet, but also of seeds, which is particularly true for wheat, corn, and soy, through the contact of the leaf material of thorn apple in harvesting machines. So it's also this cross-contamination, which is very important. And there's also a new limit for grain-based baby food. However, there is inexpensive and fast on-site screening we are lacking, and that is why there has been a rapid test for tropan alkaloids developed by our colleagues from Wageningen, which have developed an indirect competitive lateral flow test for atropine, utilizing a novel approach for sample preparation, and they successfully analyzed the buckwheat at a regulatory limit of 5 microgram per kilogram, which is a very good result of FoodSafer as well. Other relevant case studies include the study and also developing portable machines for combating illegal addition of chemicals, especially for lead bromate in turmeric as a highly sought after spice, and also advanced bioanalytical systems for testing quercetin alkaloids, plant toxins, genotoxic carcinogen, and also tropan alkaloids, as pointed out before. What's missing here, but which will be pointed out by and presented by Michele Suman, furanes in tomato sauce as an example of a process contaminant. To actually, again, coming back to what I said before, conclude that in FoodSafer, we are accommodating process contaminants, illegal addition of toxic chemicals. We're also dealing with these natural toxins and also AMR viruses. And this is fit into the digital hub, as pointed out before. Again, thanks to our partners, thanks to the consortium, and with my word AMR, which I've just mentioned in my last sentence, I think that's the ideal point in time to hand over to my colleague, Lorraine. I hope she's still here. Yeah. And I'm looking forward to you.
Thank you, Rudy. We just need 1 second to get the slide set up. Thank you. So good morning, everyone. My name is Lauren Alteo, and I am a senior researcher at the Austrian Competence Center for Feed and Food Quality, Safety and Innovation, FOXI. And today I have the pleasure of presenting work package 2 in the FoodSafer project. So I will provide you an overview of our work on microbiological case studies. So as Rudy already alluded to today, our food systems face many different challenges, some of them being related to climate change and globalization, others related to changes in consumer preferences and different food chains, which influence, changes in our supply chains and access to different supply chains. So in FoodSafer, specifically in work package 2, our goal is to expand our knowledge on existing and emerging microbiological risks, and to provide tools, methods, models, and guidance and training for people across the food supply chain, including risk managers, researchers, to address these challenges. So I will give you an overview of our 5 different tasks within the microbiological work that we're doing. So the first is in regard to the food chain lab, which is mapping peculiarities across the food chain. The second is looking at understudied or low regulated food production chains, so investigating microbiological risks along these chains in food products. The third is related to Listeria monocytogenes persistence. The fourth is really touching on this emerging hazard, so the hepatitis E virus in imported meat products. And finally, also related to emerging hazards, looking at aquaculture in terms of antimicrobial resistance, which is also a really understudied aspect. So I'm going to start with the food chain lab. So this is a part of the project that is wrapped up in March of this year. And Food Chain Lab is a software that was created and established by the BFR in Germany. They have looked into using a questionnaire. They've investigated different food business operators by asking them what functionalities they would need to improve this software to allow them to have better traceability, improved transparency, and improved food safety across food supply chains. So the takeaways of this are really that local supply chains compared to global supply chains require additional support. They face greater challenges and require new solutions for improved technologies for food safety management. So the work is still ongoing beyond FoodSafer, but they have implemented some of the feedback from the food business operators and are optimizing this software further for better use by food business operators. So this is just an overview of some of the outcomes of this particular task. They have an abstract book available, a report regarding all of the work that's gone into this particular case. There have been some presentations that were done. There's currently a publication submitted to Food Control, and finally our deliverable for the project, which is also publicly available on Zenodo. So the next case study deals with investigating microbiological risks across different food case studies. So in FoodSafer, we chose 6 different food cases. Okay. So our challenge here is that these particular cases we selected are understudied or novel food production chains, and they're related to changes in consumer interests. So the 6 case studies that we selected include ethnic foods. So these are products brought into a specific country from other places around the world that may use local ingredients, but really keeping within the custom of the country from which they originate. The second is artisanal dairy. So these are cheeses that are produced often with raw milk in a small production setting. We have last mile ready-to-eat delivery, which was something that became even more popular in the pandemic, where people are ordering food to their door in different formats, and we don't really understand the food safety of these products. The fourth is fermented vegetables. This is also something that became really popular during the pandemic, where people were doing their own spontaneous fermentations. Aquaponic farm foods, which is a new sustainable technology for producing food in an urban context. And finally, the rise of plant-based proteins, which with the rise of vegetarianism, veganism, and flexitarianism, this is something that is also on the horizon. Okay. Yeah. So many. Okay, so we investigated both total plate counts as well as different pathogens across these different products. And this is just an example of some of the pathogens we investigated. So we have hygiene indicators, including Enterobacteriaceae. We look for Salmonella, Bacillus, E. coli, and in other products we investigated Staphylococcus aureus, also for Listeria monocytogenes. And the goal of this work is to generate a catalog as a product to show other researchers, also risk managers, what microbiological risks are present in each of these different food types. And our goal also is to generate a series of publications on the results of this work, which will be published hopefully by the end of September in the International Journal of Food Microbiology. This brings me now to the next case study, which is the rise of zoonotic viruses in food products. So this is work done by the University of Burgos and the University in Poland, our 2 partners. They are investigating boar and pork meat products confiscated at the border And they're using a PCR-based approach to investigate these two different product types. And right now they have found in pork products from Spain a prevalence of about 19%, while in Poland, prevalence of only about 2%, and from the boar meat products, about 28% from Spain and about 1.5% from Poland. So this is ongoing sampling and work that's being done, which will also report in a report and a publication. And next we have the aquaculture. So one more slide forward. So we have insufficient data regarding the presence of antimicrobial resistance genes in aquaculture systems, particularly in closed aquaculture systems where the water is continually recycled. We wanted to investigate the antimicrobial resistance genes in these aquaculture raised fish. So what we've done is collected 84 samples from across 4 different partners, and these include closed and open aquacultures. And what our partners at the BFR have done, as well as the partners in the partner countries, we've enriched the samples in buffered peptone water. And at BFR, they performed a MyBaits enrichment protocol to really amplify the genes related to antimicrobial resistance, and then compared them to ResFinder. And what was identified were 162 different antimicrobial resistance genes, 10 different carbapenemase genes, and the investigation here is ongoing. The next goal is to try to isolate some of the organisms that may harbor these genes, because at the moment we can't necessarily link the gene to a specific bacterium. And the final case study that I'll present is the Listeria persistens, which is the case study that I work most closely on. So as many of you may already know, persistence is a great challenge for food producers, where pathogens are able to establish, so they're repeatedly introduced, but some are able to establish within food processing facilities over long periods of time. And this is despite the cleaning and disinfection procedures, and this may result in recontamination of the final food product. But we face many challenges in the study of persistence. This includes the fact that we don't have a current consensus definition for this phenomenon, and we have no traits or phenotypes that robustly explain this phenomenon. So our approach in FoodSafer was to do a harmonized sampling approach across 3 partner countries. So we sampled in Spain, Greece, and in Austria at 3 different sampling time points. We collected overall 1,194 different swabs and found an overall prevalence rate of 26% positive for Listeria monocytogenes, which is quite high. And in the end, we resulted in 280 Listeria monocytogenes isolates, which we then performed whole genome sequencing on. So our goal here with these isolates in the next steps is to identify which of these isolates are persisters. When we're doing this, taking a genome-based approach where we look at the single nucleotide polymorphism differences. We're also looking at the context data, so how often was it repeatedly isolated, where was it isolated, and how many times was it isolated. We're looking at gene presence and absence, as well as the coworker microbiome at the given location where the isolates were found, and assessing them phenotypically using biofilm and biocide tolerance assays. And our goal here is to develop a resource which will be hosted on the digital hub, which will use a multivariate food predictor tool. And this will take into account all of these different aspects. So the genome, the metadata for our isolates, the phenotypic data, and This will allow us to estimate how accurate our prediction for persistence is, but also which factors might be most important in explaining this phenomenon. And just a little hint at our crossover to a different work package. So work package 5, which deals with resilience modeling. So the concept of resilience is this idea of the food system to respond to food safety shocks over time. And so in our model in particular, we're taking Listeria monocytogenes contamination as a food safety shock and measuring the system performance, looking at the number of contaminated cheeses that are not safe for consumption. So with over 100 CFU per gram. So these are considered non-safe for consumption. And we've combined a quantitative risk assessment model with an agent-based model where we look at the probability of contamination of different agents, so different machinery, different surfaces within a food processing facility. And we can then estimate the performance of the supply chain. And so just to wrap up, this will be hopefully contributed to the digital hub and will be a resource for food safety professionals, including the Persisters database, some of these tools and databases that we are developing. So keep an eye out for this. And finally, we hope that the work that we're doing will provide improved ability for source tracking, to catalog these microbial food risks. And we've developed these models for improved predictive and quantitative assessments. Our publication will provide access to data and to the findings of our work. And this work will also be contributed to lifelong learning materials, which will serve as an additional resource for food safety professionals. That brings me to my final slide. So this work is not done in isolation. I want to thank all of the partners from the project across the consortium and also the European Union for funding and supporting this work. Thank you.
We'll now take a short break for 20 minutes. Please feel free to grab some refreshments and connect with fellow participants to exchange thoughts and ideas.
Food brings us together, whether it's a meal with loved ones, a quick bite on the go, or a gourmet experience. But what if every bite you took felt safer, smarter, and more trustworthy? Every day, millions trust that the food on their tables is safe. But with emerging hazards like new pathogens, chemical contaminants, and global supply chain complexities, ensuring food safety is more challenging than ever. Traditional methods struggle to keep up with these evolving threats. Introducing FoodSafer, a groundbreaking initiative funded by the European Union's Horizon Europe program, uniting 19 leading organizations across academia, research, and industry. FoodSafer is revolutionizing how we identify, assess, and manage emerging food safety hazards by developing state-of-the-art tools and frameworks. Our aim is to transform food safety in Europe and internationally by hosting a community of professionals who can work together in proactively identifying and managing emerging risks, ensuring a safer and healthier food supply for everyone. At the heart of this initiative is the FoodSafer Open Digital Hub, a centralized platform offering access to cutting-edge data in trend analysis, collaborative workspaces for professionals, guidance and training resources, proactive risk management frameworks. By fostering a global community, FoodSafer ensures that food
Our next session will be presented by Mr. Cormac McElhinney from the Food Safety Authority of Ireland. He will be speaking on the FoodSafer Hub and its application by food safety authorities. Please join me in extending a warm welcome to Mr. McElhinney as he takes the floor.
Good morning, everyone, here in the room and also online. My name is Cormac McElhinney and I come from the Food Safety Authority in Ireland. We're a regulator, a state regulator. So I'm going to give you a perspective of an emerging risks practitioner. So I lead the emerging risks group in the Food Safety Authority of Ireland, and I also sit on the European Food Safety Authority's Emerging Risks Exchange Network, and also work closely with FAO in terms of emerging risks and foresight analysis. So really, I'm going to give you a view of what we do in practice in terms of emerging risks and how this FoodSafer hub and project really is so beneficial to the work that we do. I find it very easy to promote the FoodSafer hub because I see it offers huge value to the emerging risks community and emerging risks practitioners globally. So just to set the scene a little bit, I know there's a number of definitions and a number of key terminology in emerging risks, but I think this image really, for me, sums up what emerging risks is. It's about sharing information and gathering key information in a timely manner. And I use the analogy of a jigsaw because us as a food safety regulator, we only have one view of the food safety system. It's the regulator's view, but there's so many other people involved in the production, processing, sale, and consumption of food that really, to get the whole picture of emerging risks, you have to speak to all of these different players along the food chain and gather all those pieces of information in a timely manner to build the picture. And everyone along the food chain has pieces of the puzzle. And when we're dealing with emerging risks, the puzzle is usually very vague. We have very scant information, very little data. But if you speak promptly and quickly to the key people along that food chain, you begin to build a picture And the sooner you build that picture, the sooner you can mitigate the potential threat from food safety. Because we must remember the reason for doing all of this work and the reason for understanding emerging risks at the end of the day is to protect the consumers. So the sooner we understand it, the sooner we can mitigate it, and the sooner we can help protect consumers. So I'm not going to go into huge detail on this slide, but this is the FSAI's emerging risks identification and screening system that we call ERIS. Okay, so along the top, you can see these number of red circles. And basically what these are inputs. We consider them inputs of information or signals. And we take signals from so many different sources. For example, we have an automated system that reads 12,000 published papers per year, specifically focused on emerging risks in food. We have a number of AI systems that monitors digital and social media for food safety risks. We're involved in a number of national and international networks, fora, where we gather information and intelligence around emerging risks. We have a number of advanced data analytics systems that mine trade information, for example, and mine online information for food safety risks. We also look at trade flows and commodity and general intelligence, especially around the likes of food fraud, for example. And this is just it's a non-exhaustive list, but just to say, we've lots and lots of inputs that come into the system. So we've lots of signals and we've lots of generation. And when I get to the end of this slide, I'm going to show you how FoodSafer taps into each of the points in this system. So when we generate the signal, it comes in as an input. So we generate one of two notes. One could be a situation report, and this could be a 1 or 2 page document on some strange signal, and we want to capture the point in time. The other one is an emerging risks briefing note, and this briefing note is somewhat modeled on the EFSA system because we work very closely with the EFSA colleagues. And this is a more extensive briefing note. The initial briefing note we wrote on the Ukraine crisis was 32 pages long to understand the threats to the EU food supply system. So the second one, the briefing note, is quite extensive. So when we have these inputs generated from the signals, these then come into an emerging risk screening group. And this is the key point because this is a human-centric system. Here we're talking about systems, here we're talking about data, but really the emerging risk screening group in Ireland is human-centric. We have 13 domain experts that sit on this group from across the organization, so we can tap into huge expertise. And basically this system then, this group meets 4 times per year and screens the emerging risks note that come in. So it's a highly transparent system. As you can see here, everything that comes into the system has to be acted upon. We just can't sit on it and say, okay, there's a signal, because once it comes in, we're a food regulatory authority, we must respond to it. And we evaluate each of the risks that come in, or each of the emerging risks that come in. You can see here, we have 7 criteria, one on novelty, one on exposure, scale, severity, how reliable are the sources. We wouldn't rate something that's just posted on Twitter the same way we would rate a peer review publication from an authoritative source. Imminence, how likely is it to happen? Is it happening now? Is it happening in 6 months' time? Is it happening in 20 years' time? And reputational risk. What's the reputational risk from such an impact? So we score it based on this qualitative risk assessment. And then we also asked a number of considerations. Have we noticed it before? Is there any further data? Do we need to engage other stakeholders? And then when we've all this discussion and all this peer review, we have then a number of recommendations. Okay, we now understand the emerging risk. What do we do about it? And a lot of the time it's okay, we know at a point in time, we need to speak to other stakeholders. We need to go out and do some risk assessments. We need to go and do a survey, whatever it is, consult other bodies, for example. So we have a number of recommendations then, and then this feeds in, this may then feed into the business as usual system within the Food Safety Authority, maybe into our biological experts or our chemical experts, bring in this new risk into the chemical sampling plan, for example. So you can see where I put the FoodSafer logo. So we currently use the FoodSafer hub as a signal identification tool. You can see the RSS feed that was shown earlier by colleague Christina. That's essentially doing this work for us. It's showing the signals, it's showing the trends, So we take this as an input that comes into the system. We also use it within the emerging risk screening group as here in the consideration, should the emerging risk screening group start exchanging information on the issue. So we mightn't have enough information at a point in time. Then we feed it back into the FoodSafer hub. We draft a note and we ask the colleagues then to contribute to it. And then thirdly, around the recommendations, where we consult other bodies or others. Again, we can use the hub for that, or go onto the network and you say, okay, maybe there's a situation starting to develop in the Middle East, in Africa, in China. Okay, we go onto the hub, because when you're speaking about emerging risks, you have to speak to people that understand emerging risks. And the guys registered on this platform and this hub understand the concept of emerging risks. So when you get in touch and you try and discuss it and try and develop more intelligence on it. So that's where we use the FoodSafer hub within the system that we have in Ireland. Here you can see, this is, I suppose, a timeline to give you an understanding of how we deal with emerging risks. We have a number of data sources and inputs that come into the system. Ideally, where we want to be is predictive analysis, but we know the challenges with that. Okay, so we also have data to do with real-time monitoring. As I said, we use AI-driven social media and digital media tools, communications dashboards, for example. So we use these to identify immediate trends. Is there something happening right now that we need to be aware of? We also look at short-term trends. For example, this is more of an early warning system where we'll be monitoring the RASIP database. We have our own internal database for this database of rapid alerts. And we have our own internal automated response management system that looks at helplines and understands complaints and deals with internal issues within the state. Then we go into intermediate monitoring. This would be the likes of chemical sampling plans, for example, and efficient controls. And again, we can mine this to look at short to medium term trends and do some predictive analytics from it. And then really, when we're talking truly about emerging risks and the horizon scanning, really we're talking a time frame of 6 months out to 20 years. It's way out in the horizon. All the stuff back is probably business as usual for the Food Safety Authority. But we do mine all of that data from an early warning and emerging risks point of view. And again, where does the FoodSafer hub come into all of this? You can see along the 3 time horizons, predictive analysis. You heard from some of the discussions earlier from colleagues around predictive systems to do with mycotoxin identification and mitigation, and some of the microbial predictive tools that are going to be developed and hosted on our hub. Again, in terms of short-term trends, early warning, you think of that feed, that RSS feed. This is doing the work for us. It's giving us the early warning system. In addition to the official data, there's so much information out there that's open source and so many signals out there. Again, it's curating that information for us. So we don't need to go and develop scrapers. We don't need to go and trawl through lots and lots of literature because we're only a small team. So we need these systems to support us. And then the medium to long-term trends. This is the discussion piece. You know, this is the collaborative piece where someone says, the likes of Professor Kruska talking about aflatoxin B1 being an emerging risk. I'm surprised by that. And then I say, okay, how is it? And then we have a discussion. We say, okay, it meets the definition for the emerging risks from EFSA. And then we say, okay, this is new information, this is new intelligence. In terms of the long-term horizon scanning, do we need to start updating our chemical sampling plans? Do we need to raise this issue with EFSA? Okay, there's a number of systems already in place, but if there's an increased exposure, do we need to start targeting specific commodities, for example, from specific regions where this exposure may be increased? So, as I said at the outset, people and communities are key to this. You can set up a system and you can have all the technology in the world and all the data in the world, but at the end of the day, it's humans that will make the decision. And there's a lot of disruption around the AI, using AI. And if you're familiar with the AI Act, there's this idea of a human in the loop or an expert in the loop, and it's enshrined in law. And it's there for a reason, because these systems aren't making decisions. And in order for food regulatory authorities or communities to make decisions, humans have to do this. This is, I suppose, again, a non-exhaustive map of the national and international collaboration that I'm involved with the Food Safety Authority in terms of emerging risks. You can see a lot of organizations here, the WHO, the FAO, Codex, a number of our own internal official agencies, FoodSafer, EFSA, scientific committees, for example. And all of these guys are actually on FoodSafer. We've spoken to them all. We've engaged with them all on a number of events. So they're all represented on there. So you have direct communication with the key agencies globally to address emerging risks. And we had a recent interesting session with the FAO in Rome to develop an international framework for early warning and emerging risks. Discussions came up around the use of INPASAN and the use of the FAO networks. And really, the FoodSafer hub offers a complementary tool to offer this early warning signal identification system. And again, with colleagues in EFSA at the Emerging Risk Exchange Network, again, it's a tool that complements a lot of the work that's there, because this tool is really about sharing signals, sharing early information, and then that's collated and brought into these systems. So it helps with a lot of the work we're currently doing. I'm going to give you a quick top-level overview of a number of engagements I've had in terms of showcasing the FoodSafer hub to some of the networks. One here is IBEC. This is the Irish Business Union in Ireland. It represents over 10,000 member companies. So we met with them. There was huge interest from the food community there. There's a small group that we work with, the Emerging Risks Threats Forum. So they understand the whole idea of emerging risks. And this has led to fruitful discussions. And I know a number of European groups are interested in further discussion around the use of FoodSafer. So we've developed a number of closed groups within that. As you can imagine, this is a trade body, and we've offered to support them in order to for them to exchange information, even without the regulator in the room. Like we can set up a number of different workplaces or workspaces within the hub. And as Christina alluded to earlier, these are secure workspaces to allow people to communicate and collaborate on all things emerging risks. The next one here is the EFSA Emerging Risk Exchange Network. And you can see from our recent report, we had a recent meeting in Tallinn in Estonia a number of weeks ago. And you can see the readout from this. So the EFSA ERIN network use FoodSafer as an input as well. So they have a member of staff that's actually tasked with screening and interacting for EFSA from their emerging risk group. And you can see here that FoodSafer is mentioned in the final report. Examples illustrate the depth of monitored topics and options for sharing early views on the news via FoodSafer, enabling exchange of views and potential prioritization. And just to say, each year, EFSA, with its network, analyze around 60 emerging risks. There's lots of emerging risks, but when it comes into the EFSA system, these are full briefing notes with full discussions that has the view of all the member states, plus a number of other international organizations, including FAO, WHO, for example. I mentioned earlier around the UN FAO exercise that we ran in Rome recently. It was a week-long technical session to develop this international framework for emerging risks. There is a summary report available, and we can make it available afterwards in terms of the link. So this idea was to bring, I suppose, an international community together, not just a European community, an international community to develop this framework. And there was a lot of countries there and a lot of organizations there that showcased their best, I suppose, best-in-class systems that they have in their various countries. So the idea is to come up with an international framework. And again, I would see the FoodSafer hub as providing that tool and that backdrop to support that work. I'll leave that for you, that summary report for you to consider later. With another session down in the Middle East, supported by Professor Godfrey here in the room, where we went down into Oman for a couple of days, and we met with a number of the food safety authorities from the Arab regions. And again, we showcased the tool down there, and really the response from that group was very favorable in terms of having a system that's global, it's global outreach, and it can be used for sharing early warning signals within a global system. So I'm going to show you a little case study, and I showed this in Oman to let people understand how does this work in practice. So the hub is here. You've got lots of collaboration, but how does it work in practice? So if anyone's familiar with highly pathogenic avian influenza, we've been monitoring this for about a year and a half from the early stages when the outbreaks started in the US. And HPAI has been around for a long time. But this particular case was interesting because it had jumped from basically poultry into dairy animals. And that has happened before. But in this case, it went from poultry to dairy animals, and then it started to move through dairy animals. And it's since jumped many species. It's gone into, there was a case in the UK where it's transferred into sheep. It's transferred into cats, dogs, alpacas as well, as I believe. So really, from our point of view as a food safety regulator in Ireland, we have a dairy industry that's worth multiple billions, I think around 7 billion of an export market, and we have a very big infant formula industry. So of course, when we hear about highly pathogenic avian influenza going from poultry into dairy animals, we get quite alarmed and quite concerned, because if it comes into Ireland, it's going to be a major issue for the industry, and also for us as a regulator to deal with it. So really, we want to get out ahead of this. So we use the FoodSafer platform. As you can see, these are screenshots from the early discussions where we say, okay, here's an initial outbreak. Here's the link to it. Has anyone else seen this? Colleagues from EFSA came on shortly afterwards, a couple of days afterwards, and they said, look, in collaboration with the ECDC, the EU Reference Laboratory on avian influenza, they've drafted up this new report. So automatically there was a discussion starting to happen, and other people could see it, other countries could see it as well, because it's fully transparent. So we continue to monitor it, and a few weeks later, then we have a report from our own internal Department of Agriculture, where they say, okay, we don't have it in our flocks, we don't have it in the dairy animals, but we need to set up a sentinel system to see, is there any risk here? And you can see here that this is the first case of bird flu, HPAI, detected in a wild buzzard. So that was the first case. And then this was shared, and again, another discussion to say, okay, there's also other wild birds and other species in other countries. So then there was a further update in terms of, okay, the response in Ireland was to issue a housing order for our poultry, bring them indoors, protect them from wild birds, and stop it moving through the flock. And again, this was shared, and the map, you can see here, there was a map produced by colleagues in University College Dublin. And at that point, there was 19 birds detected then across many species. So you can see it's going fairly widespread. So we shared this information again. EFSA then came back and said, yeah, by the way, we've done some further work. We've mapped the European issue to do with poultry, all birds and wild birds. So now you can see there's a map of all the HPAI cases in poultry and wild birds. So if there's a member state concerned, you're getting the real live data. And the point around this, especially down in Oman, is to showcase it. When we speak to colleagues in the Southern Hemisphere, maybe in Australia or New Zealand, usually food safety issues are maybe 18 months ahead or 18 months behind because of trade flows or because of weather patterns. And history it does repeat itself in certain areas, you have certain signals. So the point to the colleagues in Oman was they drafted these two papers recently. One was the first report of human infections of avian influenza, the need for a One Health approach, and then a question, how concerned should we be about the recent avian influenza outbreaks? So all the lessons learned and all the information and data is up there on the hub for them to see it, the type of birds, the type of responses. So all the information is there because we're probably doing similar work. Our teams are getting smaller, resources are getting tighter. So let's share the information where possible. So a quick recap from a food safety regulator point of view. So we see it as a key tool in the FCI's emerging risks toolset. But collaboration and engagement is key among stakeholders. And I can't emphasize that enough. It's about the community, it's about the expertise. And there's no point in having a great group of people together with great knowledge and great expertise if we don't share it and engage on the topics. There is limitations around sharing sensitive and official controls data. I get that. It's written and enshrined in legislation. We can't share official controls data, but we can share summary statistics. We can say, okay, there's an increase in HPA in wild birds. We're not going to give a data set, and that's the same across other authorities, but we can share information, share reports, and have offline discussions for those that are interested. The FCA is the user for engaging stakeholders who may be hard to reach. For example, some of our industry groups, we may only meet them once a year, but we use this system then in a closed group to share information, share signals where we wouldn't usually have access to them. It offers the big picture from authorities and informed sources. And again, this comes down to it has been mentioned before about the wisdom of crowds, the wisdom of expert crowds. You couldn't buy the knowledge that's on this platform if you tried to pull them together, and it's there. We just need to use it. However, the system gets exponentially better the more active users it gets, and you can see active there in bold capitals. We need to be active on the system, but we see this tool as being highly beneficial as an emerging risk practitioner. Others may not see it like that. They may see it as a hub for posting or hosting project outputs, but as a food safety emerging risk practitioner, it's hugely valuable in order for sharing and discussing signals. I have some contact details there, and just to acknowledge my collaborators that are involved in this as well. There's a group, Wayne Anderson in Ireland as well, and Iris, who's been great support in Work Package 4. So thank you very much. And if there's any questions, I take them.
It is now my pleasure to introduce Dr. Michel Suman from Barilla, Italy. He will be presenting on the importance of the FoodSafer hub for the industry, offering valuable insights from an industry perspective. Please join me in welcoming Dr. Suman to the stage.
Good morning, good afternoon, good evening to all the connected people and colleagues and to the people here in the room. I'm very pleased now to take you in a half an hour journey about industrial perspective of the FoodSafer outcome, and in particular what is going to the core of the FoodSafer hub. From the industrial perspective, going into more details about the chemical perspective of what is inside the project. So, because we are talking about the chemical perspective, you can have here a look at what happened in the first year of the project when we were, let's say, thinking together with our advisory board, international advisory board, about the current and emerging chemical food safety risks. And you see that this kind of picture is reflecting also, at least most of these, which what Professor Kruska showed in the start of this meeting today about the EFSA reporting. So you see that part of this cake is mainly represented by toxins, and then you have the presence of pesticides, which could be considered quite classic, let's say, contaminants, even if we have emerging toxins, for instance. And then we have new kind of categories of contaminants like PFAS, which are growing in the sheen in this period. And microplastics is another great topic, let's say, of the last period. So some of this is surely in the core of the project. And here you have the different activities that were already mentioned by Professor Kruska in the introduction, so I will not go again into details of this. But what we are going to do is now to enter into more aspects and details about these different tasks and see where there could be a direct impact or a potential future, close future impact from the industrial point of view. So let's start with the first one, which is mycotoxins prediction. Mycotoxins, you know, are secondary metabolites of the fungal metabolism in the plants mainly, and they consequently can enter into the food and feed chain. And what is clear is that their impact can affect different stages of the chain, from the field to the storage, etc. and having the possibility to manage better the different aspects that influence their development in the finished products at the end, and acting earlier from the field is particularly relevant. And this is one of the reasons why we were concentrating the attention of FoodSafer about predictive modeling and monitoring of multi-toxins profile in consecutive harvesting campaigns. So the first activity was about the prediction models, and we started looking to what was present into the scientific literature up to the start of the project. And you see that this is the picture obtained where practically we have most of the available scientific literature is relying on the classic, let's say, well-known, regulated, at least part of them, mycotoxins in classic, let's say, chain like wheat, for instance, while we do not have availability for emerging toxins and for other kind of chain, like, for instance, for tomatoes, just one model we have found in the scientific literature. And these models are relying clearly on main input parameters like temperature, relative humidity, rainfall. What we want to do is integrating also some new kind of sources of input. You will see that satellite data, for instance, is one of them. So the project is working not on the, let's say, well-known mycotoxins regulated, but the emerging mycotoxins like Alternaria, ergots, eniatins, and covering different kind of grades in consecutive collected data from several years, and particularly from the 3 consecutive years from the start of the project you will see later on. So we are actually working in progress into different machine learning calculation for different kind of predictive models for these emerging toxins. In parallel with this, I would like now to have a stop on this first part, saying that if we have to think about to some kind of potential industrial applicability of these activities of the project, we can imagine to integrate in the core of the project, in the digital lab, this kind of predictive models, and having the possibility to select potentially in the future different geographical regions and correspondingly different risks for an emerging toxin with respect to another, depending also on the climate condition of that region. Having a tool for forecasting and monitoring the occurrence, the concentration of mycotoxins in different regions is also useful. We can collect and create a population of data year by year in the digital lab about the monitoring profile of this toxin in different areas of Europe and potentially out of Europe as well. Also, having the possibility to integrate this kind of hub maybe into higher or let's say wider service platforms, and thinking about something that could be a service for large-scale farms or other kind of agrotech cooperation. This is a kind of future we can imagine. What about the measurement consecutively of profiling of mycotoxins in different geographical areas and for different kind of grains and commodities? What we were starting to do is related to the fact that, as anticipated in the introduction, that we have to deal with climate change and to the fact that there will be a shift of the different kind of risks in the different regions. And so if we, starting from this pattern that was illustrated in the introduction, want to go into details, the project started in 2023, so in the first year, with the first harvesting campaign collection from different kind of countries in Europe, like Italy, Germany, and Turkey, Greece, etc., for contemporaneous collection of data and samples from durum wheat and common wheat as well. And we are now having something like more than 240 samples, because we completed also, let's say, the second year campaign for the durum wheat. And we are now going into the 2025 execution of the third harvesting campaign. In a similar way, sorry, it was too quick. Okay. In a similar way, What we are doing also to work on the tomato chain, and we were considering the main production regions for tomatoes in the center north of Italy, selecting all the relevant locations and field, and working also with the idea to take into account of different kind of agricultural rotation, and collecting already more than 100 samples for the first two campaigns, and again we are doing the same in the present year campaign. We started already to analyze the data and the samples coming from 2023 and 2024, and the picture that I can already anticipate to you is that most of the grains contain, for instance, some amounts of alternaria metabolites and some, let's say, classically eniatins, deoxynivalenol, for instance, which could be quite expected, while we have only sporadic detection of ergot alkaloids, and also maybe because of lucky campaigns in the last 2 years, the presence of expected alternaria toxins in the tomato chain was relatively mild. That's the situation that we were measuring, and it's very, very summarized situation, because the method we are applying is measuring close to 1,000 different kinds of metabolites. So we are making a data elaboration that I will maybe present to you next year with all more details and profiling of the different metabolites in the different areas and in the different years campaigns. In parallel, maybe you remember from the start of this morning that the first, let's say, point in mind of the, let's say, stakeholders for the classic food safety risks is represented by the pesticides. So what we are also doing is taking sub-selection of these harvesting campaigns in order to measure also the pesticides, and looking also for data elaboration and correlation between these information and the multi-mycotoxic metabolites that I was mentioning before. And it's just an anticipation for you. This is a picture of different areas in 2023 and 2024 for the tomatoes, of different principles that were retrieved, some of them just in traces, some let's say with amount that can be quantified, and you see that we can have some principles that are more present in the different fields, and there are also differences between, let's say, fields quite, let's say, clean, and other that could be an higher presence of traces of pesticide inside. And the picture is much more, let's say, overall complicated when you look to durum and common wheat and different, let's say, region and years, and we can again see that there are some classic, let's say, expected pesticides, for instance, pyrimidine, just to mention one, that can be significantly and frequently present, while others are practically completely absent in the monitoring. And again, what we are going to do is to elaborate in this data, combining them with the present 2025 campaign, and we will come back to you with an overall picture at the end of the project. But the other novelty is trying to integrate the satellite information. And this is an example of what the project is doing, exploiting the collected samples from Serbian areas for what concerns maize, and we are trying to correlate vegetable lineage satellite information with the data of the samples collected. We started with the 2024 campaigns, and you see here there is a first exercise of correlation of the vegetative index from the satellite with respect to the aflatoxins and fumonisin content into the collected samples. And there is effectively, especially for the aflatoxins, a correlation with respect to the values of the collected samples. And what has been done up to now is creating a model that seems promising in terms of performance, of accuracy and precision for predicting potentially on these different areas the aflatoxins and fumonisin risk through the satellite information in Serbia. Obviously, this is still preliminary, so what we are going to do is to improve this kind of results with the following campaigns in order to make more robustness in the model and in its predictability. So again, what about the potential industrial applicability? Surely, if you can imagine that the app will incorporate early warning tools like the ones that I show you, imagine the satellite measurement, for instance, or I'll give you an example also for the microbial impact, industrially speaking. You were seeing before the listeria work that has been done by the consortium. We can surely imagine that another early warning will be the database for enabling the identification of listeria monocytogenes isolates that can persist in a processing environment. This is another kind of early warning tool that we can imagine to be integrated into the hub, together with this kind of chemical prediction tools that I was mentioning. And in general, staying on this aspect of the prediction of toxins, having some kind of tools that could be integrated in terms of identifying regional trends, and this gives the possibility to imagine the deployment for the decision makers in the industry of targeted risk mitigation strategies. Also, the processing of the satellite can be of interesting already for the, let's say, fire management information system, because you could have something like, let's say, a real-time georeferencing fields, maybe with an app, with a smartphone, to refer specific fields and a specific correlation with the satellite data and the prediction of the risk, and at the same time, in a sort of early action, identify immediately the fields for a further collection of samples for parallel analysis in the lab, and all these things could be introduced in the core of the digital hub itself. What about the food processing? The third task of the chemical emerging enriched work package in the project is dealing with understanding the fate of mycotoxins and processing contaminants in the food processing. And we started with a study about the gluten-free pasta processing. And what I can tell you is that we were studying the different intermediates of the industrial processing of the gluten-free pasta. And practically the method was using a sort of sentinel, so a labeled mycotoxins within the different steps of the production, in order to follow how change the signals of these labeled toxins with respect to the natural presence one, and following this parallel sentinel and natural presence into the different intermediates of the process, we were able to arrive at the end to establish that practically during this kind of process, aflatoxins and fumones are completely stable. And this is, in any case, an interesting information if you can consider that you need to have the right management of the chain up to the ingredients, because nothing happened during the process in this case. And we are continuing the exercise now with the T2 and the T2 toxins, the BK, and this will be the new trailer for the next year. While the example about the furans in food processing is related as an example of a contaminant that is not present from the start, from the raw materials, but is relying on, let's say, the process itself. Particularly, furans started their, let's say, presence on the scene from 1995, when they were defined from the EIR as possibly carcinogenic to humans, and they started some studies for understanding their development, particularly in many heat processed foods, like baby food and, let's say, sauces, etc. Every kind of food that has a quite big impact for the stabilization from the thermal point of view, and is hermetically closed, because furans are relatively volatile. And there is a family of similar molecules of furans that constitute a sort of sum of risks that is under evaluation also from EFSA and the other authorities. But the other complication of this story is that there are several routes for the generation of furans, depending on the receipt, depending on the condition of the process, pH, the oxidation conditions, and the presence or not of different kind of ingredients, like, for instance, ascorbic acid, PFAS, etc. We decided to base the FoodSafer exercise on food sources processing. At start was monitoring the situation of the level of furans with respect to a potential guidelines of 50, 100 ppb as value to be respected. And what has been clearly identified was the fact that, for instance, tomato sauce market is very, very low affected in terms of presence of these compounds, while the meat-based one, due to the ingredient that I showed you before, mainly, is the one that can generate during the process significant amounts of furans inside. So we are working on that, and first results of the project give the idea that, for instance, autoclaving and so making a sterilization to stabilize from the microbiological point of view the products with respect to mild kind of sterilization treatment like the so-called hot filling, autoclave is definitely increasing the level of furans inside the finished product. While we have information that the pre-cooking of the meat is not increasing so much the risk, and also, for instance, we were evaluating that the presence of sugars is slightly affecting the final development of these processing contaminants inside the food source finished product. So these are, let's say, first results we obtained, and we are now working, let's say, on more details and the design of industrial experiments to study the influence of other parameters into the development in meat-based food sources. But what about, again, on these food processing contaminants, the applicability? I can imagine that in a digital lab, we can have a section dedicated to processing effects on contaminants, so introducing within it, depending on this kind of case studies, simple infographics, flowcharts that can illustrate to the operator how they have to manage the different parameters in the process in order to drive the process to reduce potentially the risk at the end. And so this could be a sort of yes or no kind of flowcharts that permit to orient the production in the right direction. And this could be something potentially useful for the industry. Then, rapid detection. This is the fourth task for the chemical, let's say, arm of the project. And we are concentrating on tropane alkaloids. They are secondary plant metabolites that can come from invasive plants that can co-grow, let's say, with the crops. And there were already some examples in the past of problems related to them because the contamination can be quite frequent in, for instance, buckwheat, corn, and some kind of specific grains. And at present, the measure of tropane alkaloids, the main two regulators, atropine and scopolamine, is based for an accurate evaluation on SCMS, so mass spectrometry, chromatography, and so confirmatory analytical techniques for the lab and for skilled technicians, relatively expensive as well. So the idea was aiming to an innovative rapid technology sensing for giving something inexpensive and available in the chain for, let's say, prevention. And it was developed in the project, effectively, this kind of lateral flow assay based on a new technology which concentrates the, let's say, alkaloids into a small piece of paper acidified after extraction. You can concentrate to increase the sensitivity of the assay in this strip of paper and desorb it in the classic lateral flow immunoassay device. And with the reader, there's the possibility in a quick way to analyze the samples or to exploit part of this strip for a confirmatory analysis with ambient mass spectrometry technique as well. So dividing the screening and then potentially the confirmation of the results. And it's interesting, this final outcome up to now of the project, because we tested this inexpensive kit, with practically a 3D printed kit with cheap, let's say, reagents as well. And we tested the user-friendly applicability with skilled operators like technicians of the lab, but also non-skilled people like, let's say, your colleagues in the office that were engaged to try to apply the test on real samples. And we came to the conclusion that substantially the applicability of the test is absolutely friendly also for non-skilled operators. So it is also another, let's say, point of merit for imagining the future applicability in all the steps of the chain of this kind of approach. Applicability means, in fact, that we can imagine that the use of these rapid screening approaches and the potential application also for non-skilled operators is something that for sure can have a potential impact for the industry. And this kind of platform is something that can be in the future expanded to other additional toxins that can be measured. Furthermore, we can imagine also that using a digital leader connected with the hub give the possibility to real time from different points of the chain to collect into the cloud with geolocation data, for instance, the analysis and putting all together in real time in the hub itself. Finally, the 5 tasks of the project was about combating the illegal addition of toxic chemicals in food. And the examples here is relying on a specific chain, which is turmeric, and the use of illegal colorants in order to increase the appearance, the color appearance of this kind of spice. And particularly, you have to consider that most of this turmeric is coming from Asian countries and from India particularly. And substantially, the project was based attention focusing on X-ray fluorescence and near-infrared spectroscopy as techniques that has been evaluated in order to make solutions for preventing the risk on the chain for the turmeric illegal coloration. And what has been done up to now is that the project tested, thanks to the collaboration with the EAFV department in Austria, of more than 70 certified reference materials to evaluate the performance of both rapid and confirmatory X-ray techniques, and testing hundreds of samples coming from the different main exporting countries, India, Ghana, Bangladesh, Vietnam, etc., and evaluating the potential presence of lead chromate as the main potential risk in terms of illegal addition, in a way that up to now, even if still in progress, is indicating a certain percentage of risk in these different kind of collected samples from the Euro geographies. And thanks to the resolution of the X-ray techniques, it's also possible to combine the information of lead and chrome presence in the same sample and have a confirmation that really lead chromate is the adulteration issue in a specific sample. In different portable and benchtop technologies in order to give a range of options to the stakeholders depending on screening or confirmatory purposes, confirmed in terms of performances to solve this kind of task of lead chromate. In parallel, several other kind of risks could be present in terms of additional other kind of colorants. And another example is methanol yellow, and the project is looking into applicability of NIR fingerprint profiling in order to discover the presence of methanol yellow as a second example of adulteration. And we are concentrating the effort now in 3 specific geographies to which the collection of samples is referred. So also this activity is in progress, identifying potentially non-compliance samples, and we are going to confirm it in the next months. What about the applicability from the industrial point of view here? Obviously, we can imagine that we could have a more transparent production and distribution practices if we have rapid tools, imaging the portable XRF, for instance, to measure the risk, and surely the possibility to control and immediately recall batches in a more efficient way, having also the possibility to enhance the rapid detection protocols for the industry on this kind of issues and integrate this kind of protocols into industrial certification schemes that could give value to the industry itself and at the same time show a better and good image, improving the consumer trust and the brand value for the industry. And finally, it's interesting also to consider that the lead isotope analysis that could be executed in parallel could give also geographical information from the sample. So the industry could combine the same kind of protocols for controlling, from one side, the risk of adulteration, and at the same time, the traceability and the geographical location of the samples for claiming, for instance, a specific geographical provenance. So at the end, what I would like to say to finish is that all this kind of knowledge from the chemical, but also from the microbial point of view in the two pillars activities of the FoodSafer projects is something that can go in terms of lifelong learning materials in the digital lab and will be stably incorporated and in a dynamic way maintained in the future. And some final emphasis to my, let's say, industrial perspective attention on the digital lab is that we can imagine this kind of platform something centralized in a positive way, in the meaning that we can really aggregate information and regulatory updates useful to be seen from the industry, the expert-driven, so the possibility that we are stably considering verified sources to which refer our future decision-making action, and having the connection with stakeholders across the supply chain, relying on the fact that we have experts in their different fields that can, let's say, speak the same language lively in the hub, optimizing also the, let's say, on-to-go, let's say, availability of this kind of information and connection with mobile applications, and having finally the possibility to exploit it also for an informational purpose in the sector, thanks to a continuous pipeline of information about EU or global upcoming events relevant for the stakeholders and for the food business operators. So with this, I would like to make a big thanks for all the people that were involved and the different organizations involved in all the tasks and activities that I showed to you. And also, I would like to thank you for your kind attention. Merci beaucoup.
To conclude our program, we are honored to welcome Professor Samuel Godfroy from FoodReg-Sci and G-Force. He will be delivering a presentation on collaborative leadership in action, the role of engaged food regulatory science networks. This session will highlight the critical role of collaboration and leadership in advancing food regulatory science. Please join me in welcoming Professor Godfroy to the stage.
Thank you very much again for all colleagues who have joined us online, and I apologize again for this voice, the sick voice. So hopefully we'll go through this presentation. I'm going to try actually to build on some of the presentations that were made and also share a few opportunities of the way we could leverage the outputs of the work that is being conducted through FoodSafer, and also through the creation of the digital hub in order to serve particularly food regulatory science communities. Now, obviously, we're organizing this event on the margins of World Food Safety Day, and the theme this year is about the contribution of science to food safety, both in being able to predict emerging issues, but also to address those. And just a reminder of the importance of food safety, if it needed reminder, the fact that we are facing a number of challenges that will exacerbate food security and food safety issues, primarily in relation with the increase of the world population reaching $10 billion. We know that we have an increase of food waste currently, part of which is associated also with food safety challenges. And this is a contributor to one of the issues related to climate change. Greenhouse emission gases are exacerbated by food waste. And of course, there is the impact on public health with over 400,000 lives that are lost every year as a result of foodborne illness. We know that science is there to help us address a number of these issues. In consideration of climate change, we are witnessing the development of climate-smart agronomy and precision breeding as part of the solutions to increase the yield of sensitive crops. We are also seeing the development of new technologies being harnessed for the production of protein-based foods, cultured meat, precision fermentation proteins, helping particularly also to reduce the reliance on water use and land use, which are becoming more and more scarce. And we're also, and this is, I think, joins the emerging issues that were identified in Lauren's presentation earlier, we're seeing also more going back to traditional knowledge and trying to identify some of the food sources, some of the crops that we can use that are known to be climate resilient, and even potentially other protein sources such as insects. Now, we're also finding solutions in the food production practices related to the way cooling chains are being designed and implemented, looking at using more and more artificial intelligence for forecasting. We're looking at improvement in packaging, in processes that are helping us reduce the waste that may happen, and particularly potentially increasing the shelf life of perishable products. And also, as is the case in one of the objectives of FoodSafer, we're seeing also the development of rapid diagnostics techniques and more precise techniques that are helping to associate the sources of contamination with the triggers of foodborne illness. Now, of course, I'm going to be focusing on food regulatory science. Science is also a key element for decision-making processes. In fact, it is the reliance on scientific evidence, on data and the way data is analyzed that will allow for food regulatory decisions to be considered as predictable and robust. This is, in fact, what makes the difference between arbitrary, on a whim-based decisions and decisions that are anchored in evidence and in the analysis of this evidence. And of course, this requires the availability of competencies, the availability of data, and the availability of tools that would allow to address this. And going back really to the mandate of food competent authorities that are entrusted by making these decisions, these authorities draw their mandate also from the guidance of the Codex Alimentarius Commission. And I always use this reference, CXG 82/2013, a foundational text of Codex that defines the design and the implementation of food control systems, and from which we draw what food competent authorities are expected to deliver. They are expected to deliver national food control programs whose objectives are primarily the protection of consumers' health, but also having a dual mandate, the mandate of ensuring fair practices in the food trade. And for this dual mandate to be delivered, there are a number of values that are to be espoused. The values of transparency, of predictability, and of equitability of treatment, equality of treatment rather. And to ensure particularly the predictable aspect of the decisions, we need to ensure that these decisions are based on a decision-making framework. Given that we are addressing risks, risk analysis is in fact the decision-making framework that is relied upon and that has been relied upon for many areas where risk existed. For food risk analysis was developed and was identified as the decision-making framework adopted by the Codex Alimentarius Commission in 1995, but in fact practiced since the 1960s, since the creation of Codex or even before the creation of Codex. And in fact, this decision-making framework, if I represent a food competent authority or a food control system that is anchored in legislation and in secondary legislation that is regulation, the pillars of the system where the decisions are produced, it's essentially the risk analysis framework. Risk assessment being the scientific component, risk management being the one that draws on the scientific component and overlays other considerations that are still anchored in evidence. It can be economic evidence, social evidence, trade evidence, and of course, risk communication, which is supportive of the interaction of all the stakeholder communities. And for the entire system to be holding together, we need, of course, to have a robust governance and a collaboration with support of functioning institution and, very important, the scientific capacity that will be able to fuel the risk assessment pillar. Now, I basically gave you here the definition of food risk analysis as exactly defined in the texts of the Codex Alimentarius Commission. And this is, in fact, the representation that was adopted by Codex. Simply here to mention that risk communication is not the simple communication about risks, but it is, in fact, the interaction between stakeholders at every step of the decision-making framework, from the identification of the issue, its analysis, the formulation of the options for the management, and the implementation of the management. And that's why this representation puts risk communication as the circle in which the two other aspects are included. Now, there is another driver to adopt risk analysis, and that's the creation of the World Trade Organization and the agreements of the World Trade Organization that pertain to food trade. SPS, the SPS agreement, the sanitary and phytosanitary agreement is one of those, and the reliance on risk assessment has been identified as one of the obligations of food regulators under Article 5. Also, the need to ensure that decisions are not arbitrary and are meant to consider minimizing the negative impacts to trade is another obligation that is listed as part of the SPS agreement and its Article 5. Now, going back to some of the emerging issues that have been mentioned earlier, and basically some of the drivers of change, we will be witnessing more and more the coupling of products that might be resulting from technologies and products that might be resulting from potentially traditional knowledge, like fonio and moringa, which are crops that are found in West Africa and that have been consumed for a number of years. Now, for these products, under every regulatory regime, because they do not necessarily have a history of safe use that is fully documented, they are likely to be identified as novel. And they will pose questions to regulators as to how they need to be dealt with. So whether be it new technologies or heritage-based crops, we will have similar questions that regulators will be facing. And in order to address these questions, you need to have communities of practice in food regulatory science that are able to develop the answers through risk assessment, particularly by integrating the various scientific disciplines that will allow such risk assessment, toxicology, microbiology, nutrition, but also to develop the formulation of the options of management, including through the estimation of the impacts on the society or on the economy. And in order to ensure that the decisions made are in such a way that they will not only maintain but potentially boost consumer trust and therefore support the trade of these commodities, we need to make sure that these decisions are anchored in a robust decision-making framework that is the risk analysis framework. And in fact, the absence of the reliance on this predictable framework will lead to tension. In fact, you witness in most of the situation, tensions between innovation, where essentially science evolves and produces new products, new processes, and the ability of the regulatory regimes to be able to accept into the market these products and these processes that are being developed. And the way to alleviate that tension is essentially to rely on robust decision-making frameworks and also on collaborations. And this is where I'm trying to also reposition, if it wasn't already done, FoodSafer in this particular ecosystem. We have defined, and through the various presentations, I believe you have heard how FoodSafer is there to help us identify emerging hazards. Emerging hazards or emerging issues, and some of those can be, in fact, emerging issues that food regulators will have to tackle, will have to make a decision upon. And what makes FoodSafer unique as well, beyond being a European driven project, is that it has a global relevance. And as was mentioned earlier by Professor Krushka, that global relevance is very well represented by the various organizations that either sit on the advisory committee or that are contributing to the delivery of the project itself. Now, going back to the scientific foundation of the decision-making framework, so we need, I think everybody agrees, we need scientific-based risk assessment. But such capacity is actually costly. You know how much it takes to produce a risk assessor that is able to deliver what I call regulatory risk assessments. First of all, the number of academic programs that are out there that are able to deliver these type of competencies are very limited. And most of these competencies are actually acquired through experience. And by my own experience, having had the privilege to serve within the government of Canada and actually serving within an organization that develops these processes and these decisions, after you have a graduate with a very good competency in a scientific or a set of scientific disciplines, you will need at least 3 to 4 years of practice and of experience sharing such that these competencies can be shared and developed, which means that these type of competencies are rare. And they are as rare as, a commodity can be rare. And which means that the investment in these competencies need collaboration. The first actually collaborative leadership that we can harness is obviously the international leadership. Under the auspices of FAO and WHO, we are in fact quite lucky to rely on the advice of the advisory bodies of the Codex Alimentarius Commission. JECFA, GEMRA, GEMNU, and the ad hoc expert consultations actually serve the food regulatory science community by providing risk assessments that can be harnessed by the regulatory community in order to serve essentially the global community and to level the playing field between those who have the capacity to do their risk assessments nationally and those who may not have. And you see here how prolific, if I take JECFA alone, JECFA has been quite prolific in issuing decisions related to additives, contaminants, veterinary drug residues, and in some instances, even some aspects related to novel processes. Most recently, it wasn't JECFA, but it was an ad hoc expert consultation that was hosted in Singapore that essentially looked at cultured meat, amongst other things, and defined the conditions of safe production of cultured meat. And in fact, some of the discussions now have been brought before the Codex Committee on Food Additives in order to look, for example, at the safety of media of production of these cultured meat products. Now, so that's actually one of the first elements of collaboration that we can draw upon, and particularly in the area of hazard characterization. Because when it comes to hazards, we are all humans, and if you identify the impact on human health, in Canada or in the United States, it's very likely that it will be the same in Africa or in other parts of the world, particularly that in these risk assessments or in the hazard characterization part of the risk assessment, we consider the vulnerable populations. So for the hazard part, in fact, relying on the international guidance is already addressing the need, if such international guidance is there. But when it comes to evaluating the exposure, you need to localize the information. You need to have data about what is the level of food that is being consumed in a given jurisdiction and what is the potential occurrence of the hazard. And in this particular case, you need to have local information. Now, such local information, of course, requires investment. And investment in analytical method development, investment in the development of the data itself, investment also in being able to survey how certain food commodities are being consumed. And in fact, if there is one critical gap right now in risk assessments in developing nations, it is the availability of the food consumption data to be able to estimate the exposure. So this brings actually the need for additional collaboration that is required to address these two other components of the exposure assessment, the other part of the risk assessment. Being able to develop occurrence data, being able to develop food consumption data. Some of that is actually being produced as part of FoodSafer for certain hazards, trying to collect information on occurrence, for example. And we need, in fact, to boost opportunities of collaboration that would allow regulators, either at the regional or sub-regional level, to be able to work together. I would say that two neighboring countries in West Africa, there is a strong likelihood that they will have consumption patterns that are somewhat similar. If I take the example of Canada and the United States, when we do not have data in Canada, despite the variety of the continent, the North American continent, we will be relying on some data that is coming from the United States. So in this particular case, there needs to be opportunities for resource sharing, for development of collaboration efforts that would allow to address this need. And this is where we can identify the need to develop some of these communities of practice to address the challenge of being able to produce timely information and something that is cost effective. Because not every country in the world will be able to have an EFSA, and not every country in the world will be able to have, I don't know, a US FDA or a large food regulatory agency of the likes that OECD countries enjoy, or even the Food Safety Authority of Ireland, because these are resource intensive endeavors. So this community of practice, we can actually try to use FoodSafer as a host for these, and particularly in the context of hosting within the FoodSafer hub, the capacity to create networks of collaboration, exchanging information, potentially developing collaborative endeavors, including the way to harness outputs of the guidance that is being developed and the learning tools that are being developed as part of the initiative itself. Now, of course, we're trying all to find ways to reduce the costs of regulatory endeavors, and we're witnessing a lot of developments, again, through scientific efforts, whole genome sequencing that is helping us shorten the timelines of the identification of the culprit pathogen that is the source or that is linked with the foodborne illness outbreak. We are now using, of course, the multi-criteria decision assessment systems, the MCDA systems, using AI on top of the availability of data, such that we focus the inspection resources that may be limited only on the higher risk establishments or on the higher risk products, and being able to have that early identification system. So here again, FoodSafer and the hub can be the place where you can identify those signals that tell you how to modify your decision-making processes. We're seeing also the potential reliance on portable tests for rapid diagnostics techniques and even data-driven traceability that is narrowing the focus on particular lots that will need to be recalled. So again, while some of the challenges might emerge as a result of the science, the solutions are also emerging as a result of the use and the reliance on science. And being able to collaborate in generating these solutions or in using these solutions is one way of addressing the challenge of scarcity of resources. And this is, I guess, one dream of mine that I hope will see some success at some point, which is the development of regional centers of competencies or centers of excellence, where essentially food regulatory scientists in a given region or in multiple regions, by creating networks, could be able to share the burden of the development of the data and of the analysis of the data to support, again, the robust decision-making process on the basis of risk analysis. And of course, this can only occur with collaboration, not only between regulators themselves, but also between regulators and their stakeholders, meaning academia and industry, amongst other partnerships. Of course, part of the reduction of the resources and the burden is by recognizing each other's standards, each other's decisions. And of course, that requires also stronger collaboration and stronger transparency of the decision-making processes. Again, I mean, this is another representation of what a regional center of excellence in food regulatory science would be able to do. It would be able to conduct risk assessments, to formulate options for risk management, to be able to do impact assessment, including to design a compliance verification program on the basis of requests, but also to be able to address the data gaps that are identified both at the regional and at the national level in order to be able to produce these outputs. So, of course, this can be resolved through the creation of networks, and this is coming to the conclusion of my presentation and hopefully charting a path forward. FoodSafer is entering the phase where we are seeing the production of the science and the tools that have been promised to be able to address some of these emerging food hazards and their associated risks. We are, of course, and we want to maximize the usability and the impacts of what is produced. Part of the impact is, of course, for the community of food regulators and food regulatory scientists to be able to access the information, but also to collaborate in the best use of the information generated. So what we hope to do in the next period, and this is a pre-invitation, is that through the Global Food Regulatory Science Society Network and some of the work that we have been carrying out in a number of regions and the privilege of collaborating with a number of regulators and food regulatory scientists in academia in various parts of the world, we will be reaching out to these communities and inviting them to consider not only joining the FoodSafer Digital Hub, but also identify the best way to harness the knowledge, the resources, the tools that could dare to constitute those communities of practice that will advance their objectives. We're hoping to invest, to share expertise, and to continue to empower science to help us safeguard feed and food, and of course, continuing the protection of consumers' health and enabling also the trade of food commodities, which is the basis of many economies around the world. Once again, I hope this is what we will achieve in the next period. I'm very thankful for the opportunity to contribute to this dissemination event. Thank you. So we were monitoring if there were any questions online, but there doesn't seem to be any. How many actually colleagues are online? 70. So we reached a peak, I think, of 85 or so, and now we have 70, 70 plus people or colleagues that are online. So there are no questions, it seems, online. Any questions here? I think here we have the consortium partners, so I'm not really foreseeing any questions. If there are none, I think we've reached really the point where I would like to thank all the contributors and all the consortium members for your efforts in moving forward with FoodSafer. Again, looking forward to further events of dissemination, knowledge, and experience sharing. Thank you.
As we come to the close of today's workshop, Science Empowering Food Safety Systems, I would like to thank each and every one of you for your active engagement, your insights, and your commitment to advancing food safety through science. Today, we didn't just share outcomes and tools. We reinforced the truth that safe food is not just a scientific goal, it's a shared responsibility. FoodSafer is indeed everybody's business. On behalf of FoodSafer and our hosts at FoodRegSci, thank you for being part of this important event here at Chimie Paritech in Paris, France. Before we part ways, allow me, as your AI Master of Ceremony, to leave you with one final thought. In a world where data grows faster than crops and algorithms travel farther than our food, the real harvest is this: collaboration powered by science, guided by purpose, and shared by all. Today, we witness the future, where human and artificial intelligence unite to protect what matters most: the safety of our food and the trust of our societies. So, whether you're a regulator, a researcher, or a food systems innovator, remember, you are not just part of the system. You are a force shaping it. Thank you, have a safe travel. See you in the next chapter of FoodSafer, and let the science continue to empower.
This is the last physical meeting.